Hello everyone, it's Miss Thomas, and today we're going to look at sort of an extension of domain and range and sort of taking it to the next level. As a reminder, domain is the set of all input values range is the set of all output values. So our input values in general are our x values, and our output values are our y's. So it's really important to keep in mind. If you have a hard time keeping it straight, they are organized alphabetically. So domain, D comes before R, X comes before Y. So you should really, if you put your D's and R's and X's and Y's in alphabetical order, you'll have domain and range and which variable that we typically use for functions straightened out. So a relation is defined by the rule y equals x plus 2, where x is contained in 0, 1, 2, 3, and 4. So this is a little bit different from what we've seen. We're actually given a function rule and a set of inputs. This is just the set of inputs. So it says determine the range of the function. So this is the domain, and the range is going to be the outputs from each of those. So probably the easiest way to do that is just plug them into the equation. So it'll be y equals 0 plus 2. So y equals 2. Y equals 1 plus 2. So y equals 3. Y equals 2 plus 2. So y equals 4. You can clearly see there's this pattern going on. So for the input of 3, our y will equal 5. For our input of 4, our y is going to equal 6. So our range is going to be all of the y's contained in the set 2, 3, 4, 5, and 6. So the brackets are really just grouping the numbers that are in the outputs. If we want to express it as an ordered pair, a set of ordered pairs, it's going to be 0, 2, 1, 3, 2, 4, 3, 5, and 4, 6. So which of the following defines a function? This is certainly different than what we did originally. Obviously, we can see this one has a unique output for every input, right? The zeros don't repeat. Each input has just one output. So this definitely is a function. I just do fn for function. And then this notation might be somewhat new to us. It's the set of x's and y's such that y is equal to x cubed plus 1. For all x's contained in real. So those are just for all, it's a continuous function. I can plug in any value of x. And so we'll look a little bit more tomorrow about how you can do this graphically. But we can give you some examples of numbers we could plug in to see, does it work for the examples that we have? So I'm going to go ahead and just plug in y equals 2. So if I cube 2 and add 1, I'm going to end up with 8 plus 1, which is 9. So that's only one output, so it worked for that one. When we try it for a negative number, y equals negative 3. Cubed plus 1. So that's going to end up being negative 27 plus 1, which is just negative 26. So again, my input only gave me one output. And then try fractions as well, because those are real numbers. Y equals 1/2 to the third power plus 1. So that's going to end up being 1/8 plus 1. So y equals 1 1/8. So again, it's only one output. So it appears that number 1 is a function and number 2 is a function. So let's do some sort of checking in general for C. So y squared equals x for x is greater than 0. So that's an important distinction, this x is greater than 0. I'm going to go ahead and do this over here. So, I'm going to go ahead and just plug in some values of x because we want x to be our input. So y squared is equal to 4. So if I think about, well, what are some things that y could be squared to get 4? Obviously, we all know 2 squared is 4. But then we also need to keep in mind that negative 2 squared is 4. So right away we can see when we put in an x of 4, 4 leads to 2 and negative 2. So this is not a function.
You know what 1 and 2 mean?
And then, so this final one, the x squared plus y squared equals 16, this is a lot like a problem we saw in class. This is the equation of a circle. So y squared, it's a circle.
1 plus 2 is easy.
Centered at 0 with a radius of 4. So obviously we can see it's not going to pass the vertical line test. So it's not a function. Alright, so it says for the following graph, determine the domain and range. So, domain and range are easy to list when we have just a set of ordered pairs, but when we have a graph, it's a little bit more challenging because we don't just have whole number values, we have all the values between, like in this instance, all the values between negative 1, 2, 3, 4, negative 4, and positive 4 for the x's. So keeping in mind that I'm going to kind of color code this. Domain is going to be red. Domain are all the x values being used. Okay? So when we look at it, we want to look at our x-axis. I stopped using x's here, and I started using x values here. There's no graph outside of these x values. So this x value, like I said, is a negative 4. And the x value on the right is actually a positive 5. So that means I'm using, because the graph is continuous, there's always something in between negative 4 and 5. I'm using all the values between negative 4 and 5. So the way that we represent this is with a compound inequality. Since there are points at negative 4 and negative 5, or in positive 5, we use less than or equal to signs, because it is equal to negative 4 and 5. So my lower boundary is negative 4, my upper boundary is a positive 5. Okay? And so additionally, in set builder notation, which is how we write our domain and range, we write x such that x is between negative 4 and 5, and sometimes, but not always, we can write x contained in real numbers. So I'm going to go ahead and look at the range. I'm going to color code the range in blue. So as a reminder, the range is just a list of all the y values we use. It's really the best way to think about domain and range. So y is the vertical axis. You want to think about what's the lowest and what's the highest point on this graph as far as y values are concerned. The lowest part of the graph is on the x-axis. The highest part of the graph is the top of this quadrilateral here. So the lowest point being the x-axis means our lowest value for y is going to be 0. Our highest value for y is going to be 1, 2, 3, 4. So our y's are between 0 and 4. And we just sort of put the set builder notation around it. Y is all real numbers. And this is my domain and range. So this is going to be your u-try. I want you to define the domain and range of this function. Write them as inequalities. Keep in mind that these open circles mean it's not equal to this value. It approaches it, but it's not actually equal to this value. And I'll see you tomorrow in class.